So we are going to go for the next distribution, that is exponential distribution. I think you have come across and you also studied mean, variance, everything same way we also have in exponential distribution. So here in exponential distribution, students, we see formula and we try to understand what is the probability of the exponential distribution. The exponential distribution is useful in decreasing the time it takes to complete a task. Very, very simple it is. It takes time to decrease the complete a task. This in this experiment we describe time between vehicle arrived at a toll booth. Yes, time required to complete questionnaires. Also, we come across distance between major defects in a highway. We also come across the time between goals scored in World Cup soccer match, right? So, like this, we come across in exponential probability. This is just a simple curve I have drawn for exponential distribution. This exponential distribution arrives in connection with Poisson's process. A Poisson's process is one exhibiting a random variable arrival pattern in the following sense. For a small time interval delta t, the probability of an arrive during delta t is lambda delta t. So time into the arriving time they have taken, where lambda is the mean arrival rate. The probability of more than one arrival during delta t is negligible. Means whatever the extra time for arriving it takes, it will be negligible. Suppose if you take go for flight, landing the flight time and departure of the flight time is not considered, it is negligible. So whatever distance it is going to travel and whatever the time is required, that we are going to take the probability. Similarly here in the exponential distribution, inter arrival time are independent for each other. This is a kind of statistic process, one for which events occur in a random fashion. Okay, students. Under these assumptions, it can be shown that the probability distribution function, that is PDF, they have taken for a distribution of inter-arrival time is given by f of x is equal to x lambda into e raised to minus lambda x, which is exponential distribution, students. So here, more to the point, if it can be shown that the number of arrivals during an interval is Poisson's distribution. Remember, then the inter-arrival time are exponential distributed. So, like, therefore, for this inter-arrival time, we require exponential distribution. Note that the mean arrival rate is given by lambda and the mean inter-arrival time is given by 1 upon lambda. The Poisson's distribution is a discrete distribution closely related to the binomial distribution and so will be considered later. It can be shown that the exponential distribution, that mean is equal to the standard deviation, student. That is mean is equal to sigma is equal to 1 upon lambda. Moreover, the exponential distribution is only continuous distribution, that is nonetheless in the sense that p of x is greater than a plus b for all x greater than a, which is equal to probability of x greater than b. So here we have considered lambda 1 upon lambda as our mean and variance, but henceforth instead of lambda we'll take it as alpha. So this is what the function tells you, exponential function lambda e raised to minus lambda x. So lambda is just a notation. We also take it as any Greek letter alpha. So remember this, students, very very important. Probability density function is f of x is equal to alpha e raised to minus alpha x for x greater than 0, 0 otherwise, where alpha is greater than 0. Mean is equal to 1 upon alpha, and variance sigma square is equal to 1 upon alpha square, and standard deviation SD is equal to 1 upon alpha, students. Okay, please remember this. So immediately we'll go with the example, students. Yes, so I already told you, instead of lambda we are going to go for alpha. Just replace this, and now we see first example. We'll go with example 1 for exponential distribution. So we have this example, students. If x is an exponent variable, if x is an exponential variate with 3 mean 3, find p of x less than 1 and also find p of x greater than 1, students. So like this we come across the first example. We'll start now our solution. So what we have here, students, that's very very important. Okay, we will start now. The mean they have given here 3, students, means if I take the mean they have given here, it is 3. But you remember what is the formula for mean? It is 1 upon alpha. So this is equal to 3. Means that means we can take this as alpha is equal to 1 upon 3, students. So just remember this. This is what given. This all things are given in the question, students. So what you have to remember now? You please remember the formula for exponential function f of x. We have alpha e raised to minus alpha x, where x is between 0 to infinity and 0 otherwise. I am writing the formula once again so that you please remember this formula. Okay, so here we'll substitute what is mean. Mean is nothing but 1 upon 3. Therefore, we get the exponential function f of x 1 upon 3 e raised to minus 1 upon 3 x, where x is from 0 to infinity and it is 0 otherwise. Okay, so what they have told you to calculate, when first one, I will take first one, when p is x greater than 1, means when x is greater than 1 we take the, as you remember, p is equal to 1 minus q is equal to 1 minus p. Therefore we take this variable p of x greater than 1 is equal to 1 minus p. I can write it like this: x is less than equal to 1, means if it is less than 1 I can simplify this function. If it is greater than 1 it will go to infinity, student. So therefore I have taken here this value. So this is equal to 1 minus. So now this function we know already, it is greater than or equal to 1. We know the function. So it is 0 to 1 f of x dx, students. Okay. So now we see this function we can write like this. This is equal to 1 minus integration 0 to 1. The function already you have simplified this. So 0 to 1 is positive value, therefore e raised to minus x upon 3, and this is just simplify the mean, that is alpha 1 upon 3. Now I've simplified this integration. So you know this integration already, students, that is integration is given by 1 minus 1 upon 3. I'll keep this 1 upon 3 outside. Integration of this already you know, integration of e raised to x, integration of e raised to minus x. So just write the formula e raised to minus x. You will get this as e raised to minus x upon minus 1, because constant term, that is I will take this as, instead of minus 1 I will take this as e. The integration of e raised to ax is equal to e raised to ax upon a. So here a we have taken minus 1 upon 3. So this is e raised to minus x upon 3 divided by minus 1 upon 3, students. So now this integration is between 0 and 1. So what will be the next value? Just simplify 0 and 1 limits. This is going to get 1 minus integration of this value. See, this and this 1 upon 3, 1 upon 3 will get cancelled. Minus into minus will become plus. So what I am saying is this value, just make it very little. Okay, this value will multiply, divide with this value, and minus is going to get plus 1. Okay, so we'll continue this. Fine. So here this is going to get plus, and what is going to remain here? Only minus x upon 3, integration from 0 to 1. This is equal to, students, 1 plus, first I will substitute 1, therefore e raised to minus 1 upon 3 minus e raised to 0. So e raised to 0 is 1, students. So you can substitute here 1. So what we get, this is equal to 1 plus e raised to minus 1 upon 3 minus 1. If we simplify, this plus 1 and minus 1 will get cancelled. The answer we are going to get e raised to minus 1 upon 3, students. Is it clear? So next, we'll go for the second one. Here in the second question, they have asked us to p is x greater than 3, which is equal to, again it is a positive value. So it is between 0 and 3, f of x dx. Okay. So you will simplify, substitute the value, students. What we have the value, this is equal to, I'll write now, the values from 0 to 3, our exponential function, that is 1 upon 3 e raised to minus x upon 3 dx. So remember this, students. Now simplify this. We get this as integration 1 upon 3 constant. So I'll write 1 upon 3 outside. I already given the formula, that is integration e raised to ax can be written as e raised to ax divided by a. So here a we are going to take here minus 1 upon 3. X remains x only. So remember this formula. So substitute the values now. It is e raised to minus x upon 3 divided by minus 1 upon 3, students, and under the limit 0 to 3. Please remember this. Under the limit we have taken 0 to 3. Then now you can see, so this value full 1 upon 3 and this 1 upon 3 will get cancelled. So this we are going to get this as minus. And now I will substitute here 3, e raised to minus 3 upon 3 I get. This is minus e raised to 0. This is what I have substituted, upper limit and lower limit. So I get this as minus e raised to, minus minus will get cancelled. 3 will get cancelled. So this is minus 1 minus e raised to 0 is 1. So if you simplify this, what we get this value? Already you know what is the value of e. Yes, it is 2.7. You can take the value. So if you further simplify, substitute in calculator, you'll get this as 0.6321 students. So this is how you have to simplify, and we get the answer as, so this is our exponential probability of exponential distribution. So please remember this students, very very important. We will go with the next example. So we have the next example here. Yes, in certain town, duration of a shower is exponentially distributed. So we'll go with the next example. What it says, in a certain town, duration of shower is exponentially distributed with mean 5 minutes. What is the probability that a shower will last for 10 minutes or more, less than 10 minutes, between 10 and 12 minutes? So this is what they have given the question. Very very simple it is. Just we have to understand now. So just see what are the things given here, students. I will go. What are the things given here? Yes, the things given here. Yes, so we'll go with the solution. Okay, what are the things given? Probability distribution function is given. What is the probability distribution function? Probability distribution function of exponential distribution is, so what it is given, f of x they have given, means they are saying that f of x will be, already you remember the formula, x into e raised to minus alpha x for x greater than 0. So always remember please that x is always greater than 0. Yes, x is greater than 0. Then now we see they have given it for 5 minutes. So 5 minutes they have told that the mean value is there. But you remember the formula for mean. Yes, what is mean given by? Remember, it is 1 upon alpha. But this they have told that it is for 5 minutes. Therefore, alpha can be taken as 1 upon 5. So means your function, whatever this function you are getting here, this function will become now, it is f of x, that is exponential distribution function. You are going to get this as 1 upon 5 e raised to minus x upon 5. So now you can see in the first one they have mentioned that 10 minutes or more. So you can go this to this question. They have already told you that this value, whatever we have this value, 10 minutes or more means, 10 minutes or more means what? X is Here I will write. This tells you x is greater than or equal to 10. Remember this. Suppose if they tell you less than 10 minutes means x is less than 10. And if it is between x and 10 and 12 means it is 10. This is 10 is less than equal to is less than x between this less than x less than 12. This is how you have to remember the conditions now. So we'll continue this. So what will be the probability? The first one, that is probability will be x greater than or equal to 10, which is equal to integration from 10. So what is the upper limit? They have not given, so we consider here infinity. Then substitute our f of x, that is 1 upon 5 e raised to minus x divided by 5 and dx, student. So substitute this. How will you simplify this, student? Substitute the values upper limit and lower limit in the integration. So we get this is equal to, sorry, this is equal to, students, so 1 upon 5 is constant, right? 1 upon 5 outside. Integration will be what? Integration already have told you what will be the formula for integration e raised to ax. So minus 1 upon 5 remains, integration from 10 to infinity. Again this 1 upon 5, 1 upon 5 will get cancelled. What remains here is, students, it is minus. So substitute the upper limit. X is going to become infinity now. Upper limit is infinity. Therefore, I will directly write this as it is minus infinity. And this lower limit is 10. 10 means 10 divided by 5. It is 2. Therefore, I will write minus, keep minus as it is. Therefore, this is 2. And when you simplify this, you remember the formula e raised to infinity or minus infinity will be 0 minus e raised to minus 2 remains, student. So minus into minus, this minus into minus will remain plus, and the answer we get here e raised to minus 2. If you remember, if you calculate in your calculator, it is going to give you 0.1352, students. Is it clear, students, how to simplify the exponential distribution? So in the second one, second point, they have already mentioned, already told you that probability is x is less than 10. So you can simplify, you can understand by the this one that greater upper limit is 10, lower limit they have not given, but it is positive, therefore we take 0, and this is 10. Substitute the function f of x, that is 1 upon 5 e raised to minus x upon 5, and this is dx, student. So when you simplify this further, already you came across the integration now. I will keep 1 upon 5 outside. E raised to minus ax, integration will be e raised to ax. So e raised to ax divided by x. So a I have taken here minus 1 upon 5. This is as it is, we are repeating this again, same integration, only the upper limit and lower limit is changed. So this is equal to, students, you can see 1 upon 5 and 1 upon 5 will get cancelled. Only minus will remain. You can put here minus, minus, and substitute now 10. So when you substitute here 10, students, what we get? 10 divided by 5 will be 2 minus e raised to, we get the upper limit 0. And when you simplify this, this is going to get you minus e raised to minus 2 minus 1. Substitute the value, students, you will get the answer very easily. When you substitute the values, this value you are going to get, this is equal to 0.0446, students. So this is how we have calculated the values. I can see the question now, second one. I think if it is getting confused, I will tell you. In a certain town, duration of shower is exponentially distributed with mean 5 minutes. Mean 5 minutes means you have to remember here, students, whenever they give you the any value, first where it went. Okay, so mean they have given means you have to write here directly what is given here. What is given? Mean is given, that is alpha is given, sorry, 1 upon alpha is given, that is our mean. 5 is given. So remember this, immediately you will get what is alpha. Alpha will become 1 upon 5. What is the probability that a shower will last for, first one, 10 minutes or more? Means x is greater than equal to 10. Less than, yes, it is asking less than 10 minutes means x is less than 10. Lower limit will be infinity. Remember here. Next, between 10 and 12 minutes means it is 10 less than x less than 12. It is between 10 and 12. Then probability distribution function of exponential difference distribution is f of x is equal to alpha e raised to minus alpha x for x greater than 0. Then I already told you how to find mean. Substitute in the function alpha value, alpha is equal to 1 upon 5, we get this. Then probability of x is greater than equal to 10. 10 means low upper limit they have not given here, students, so we have to consider this upper limit, that is infinity. So I take this as infinity. So lower limit they have given 10. So it is indicates, you have to remember this, you have to understand this is upper limit they have not given. So substitute the values, we get the answer 0.1352. Similarly here, students, x is less than 10. As you know, exponentially we have taken, this is always between 0. So we have to take this interval 0 to plus infinity. So we have taken here upper limit is 10, so the integration will be from 0 to 10. Function you can keep as it is, 1 upon 5 e raised to minus x divided by 5 dx, and then substitute the values, directly will get 0.046. So like this you should able to solve the exponential functions. Thank you.